This is the second problem for the Mass of Newton's Laws unit, and for this problem we're going to be covering the concept of Newton's first law. So for each of the following cases, you need to say whether the object in motion is continuing in motion, or whether there's an outside force acting on it. So for the first one, imagine a ball sliding down a hill at a constant velocity. Is there a net force of 0, or is there a net force acting on it? I'll give you a second to think about this one, and then we'll go over it together. Okay, in this case, the velocity is constant. It's staying in the same direction in the same amount. So there's no net force. And this is due to a combination of factors. The hill is pushing up on the ball and slowing it down, and gravity's pulling down on the ball and speeding it up. And that's a little complicated, and we'll do more of that in later units, but for now it's enough to know that because the velocity is constant, because of Newton's first law, the net force on the object must be 0, because the object in motion will continue in motion unless acted upon by an external force. So for the second one, imagine a bouncy ball bouncing up and down on the ground at a constant height. Is there a net force being exerted on this bouncy ball, or is there no net force? I'll give you a second to think about this one. And in this case, the bouncy ball is in a stable state. It's going up and down the same amount each time. But the thing is, it isn't remaining at a constant velocity. Sometimes its velocity is upwards, sometimes its velocity is downwards. So there is a net force. It is not maintaining a constant velocity, so there is an external force acting upon it, once again by Newton's first law. And then for one final question, and this is probably the trickiest of all of them, imagine there's a spaceship in orbit around the Earth, and it's moving at a constant speed. The speed is not changing, and that means it's in a circular orbit. Is there a net force on it, or is there no net force on it? And if there's a net force, what force is there? And I'll give you a few seconds to think about that. And this one's a little tricky, so let's take it one step at a time. We know the speed is constant, but speed is not the same as velocity. We have to think about direction also. And you'll notice that when the spaceship's on this side of the orbit, it's going in this direction. But when it reaches the other side, it's going to be going in the opposite direction. And direction is a component of velocity, even though we might not talk about it all that often. So as a result, the velocity is changing. It's not changing in magnitude, but it's changing in direction. So there is a net force. So that leads us to the question of what is the net force? Clearly it's something. And it's a common misconception in outer space there's no gravity. There actually is gravity, and that's what causes this to go in a circle. You don't experience it because you're going at the exact same acceleration that gravity goes. But there is gravity, and the gravity is pulling it in towards the center. Kind of the same way if you've ever spun a ball or something on the end of a string. As you spin it around, the string pulls it back towards the center and keeps it going in a circle. In the same way, gravity pulls in towards the center and makes this move in a circle. So there's a net force, and this entire net force is due to gravity. So as you can see from these different examples, it's not always entirely obvious when there is or isn't a net force. But if you're very careful and you pay attention to both the magnitude and the direction of the velocity, you can figure out when the velocity is changing. And after that, it's simple, based on Newton's first law, to say that when the velocity changes, there must be a net force. And when the velocity doesn't change, there is no net force. So hopefully you understood that. If not, maybe go back, take a look at the examples one more time, and then you're ready to move on to the next video.